Welcome back. So the question here is a cylinder of mass 10 kg and a radius 15 centimeter is rolling perfectly on a plane of inclination 30 degree. The coefficient of static friction, that is in US, equals 0.25. How much is the force of friction acting on the cylinder? Consider the following figure. This is the cylinder here. Its weight or mass is acting downwards. So weight is given by mg, and this particular angle, the slope angle, is 30 degree. So this angle is also 30 degree, we know, and the cos component of this weight is mg cos 30 degree, which is whose direction is this in this direction, and the sine component is along this direction, which is mg sine 30, and the frictional force is acting opposite to the direction of the roll of the cylinder, right? Now moment of inertia of a cylinder is half mr square. Thus the acceleration is given by mg sine theta divided by m plus half mr square divided by r square, which is eventually becoming 3.27 meter per second. Now using the Newton's law of motion, F equals ma, or mg sine 30 minus F equals ma, or F equals mg sine 30 minus ma. Now putting in all these values, we get the friction to be 16.3 Newton. Hence the frictional force is 16.3 Newton. What is the work done against the friction during rolling? We know that the bottommost point of the body, which is in contact with the surface, is at rest during rolling. Thus work done against the frictional force is 0. If the inclination theta of the plane is increased, at what value of theta does the cylinder begin to skid and not roll perfectly? In case of rolling without any skidding is given by mu equals 1 by 3 tan theta. Does tan theta equals 3 mu equals 3 into 0.25, that is equal to 0.75. Now theta is equal to 37.87 degree.